In this question, both the original graph and its image are shown. It's like they did the work for you. You just had to figure out what happened in between. Okay? So they're saying that we started with the red graph. Something happened, vertical and or horizontal compressions, and we ended up with the blue graph. You have to figure out what happened. So the easy way to do this is say, okay, well, I have the 0.3, 9. Something happened, and I ended up with 1.5, 4.5. Let's find another point. Let's use this minimum. We started off with 2, -8. And can you see that the corresponding point to that one is this blue one here at the bottom? Which would be 1, -4. Can you see a pattern? Something happened to your x values. What did you do to your x values? You multiplied them by something. 0.5 or 1/2. Exactly. You see, the same thing happened to the y values. Your y values also got cut in half, so they got multiplied by 1/2. This is the easy way to figure that out. I really like this way, but we have to learn a secondary method because it's going to come in later. Okay? Because later we're going to have both stretches and compressions and movements left, right, up, and down, which adds a little bit of complication to it. So another way that we could figure out this x by 1/2 and y by 1/2. But before we do the second method, let's just finish the question. The question asks us to write an equation, so an equation needs an equal sign, in terms of the function f. So we want an equation, okay? So I'll write y equals, that makes it an equation. In terms of f means f needs to be on the right-hand side. Well, if I want y by 1/2, that's vertical. That 1/2 is outside the function. In terms of f, because the original function was f, if I want x by 1/2, that has to be inside the function. What would be inside the function? 2, because x's are liars. So we're going to need a 2x in there. So this is the final answer. We've written the equation in terms of the function f. Okay. So method 2. But for this question, this definitely is the nicest, easiest method. Okay? But method 2 says, if we take 2 points on our original graph, and I call this point A and this point B, they correspond to 2 points on our image graph, and we would label this A that changed with an A prime and B that changed as a B prime. And what we do is we do a comparison of vertical distances and horizontal distances. So first, I'll do vertical. On the red graph, if you went from A to B, vertically, you see that you would go up 17. I'll put a plus sign for going up, a negative sign for going down. Would you agree that going from A up to B goes up 17? Now, when I look at the blue graph, I go from -4 up to 5. Is that right? 17 there, and this is going to be 4 or 5. So that is, no, it's 4.5, sorry. So -4 up to 4.5 is going up 8.5. And then to go from 17 to 8.5, that's cut in half. The first method I hope you like better because it is nicer, but we need to know this method as well. So if we compare the vertical distances on the original graph to the vertical distances on the image graph, we notice your y values were multiplied by a half. You're going to have to do this same thing for the horizontal distance. We check our original graph was A to B. Looks like we go over 1. 1 to the right, I'll make it plus 1. Then on my blue graph, from A prime to B prime. Roll up so I can see it. We go from 1 to 1.5, so we go also tells us the x values have been compressed. So this vertical distance and horizontal distance, it's not as intuitive in this question, but we're going to need this later when we put everything together. So that is going to be important later on. Okay, questions here? 5, 12, 13, and 14. Now, since we finished 3.3, we are ready for our first take-home quiz.